welcome back to AI Hub. In this video, we are going to build a test-to-image AI system using a pretrained diffusion model. Instead of training a model from scratch, we will use Stable Diffusion and focus on how test prompts are converted into images. I'll explain each and every code clearly, including how to set up the runtime, load the model, generate images, and build a simple interface. So let's start. Before that, we need to check whether the runtime is on CPU or GPU. For that, I need to enable the GPU. So we just go to runtime, change runtime type, choose T4 GPU. Most cases, it will be in CPU. So we need to choose the T4 GPU and save. Okay, why we need it? Because test image models are very large and requires GPU acceleration to run efficiently. So Google Colab is already providing that. Okay, and once the runtime starts, we will ready to begin. Okay, so it's optional, but we can check whether the CPU is available or not. So start with adding a code cell, then import torch, print torch.CUDA is available. If it print true, that means the GPU is available here. So for our system, for our collab, it is true. So just check if you need to verify it. Now we are moving to our project title, that is test to images generation using Stable Diffusion. Before that, we need to just write it. So this is our project name. And we need to install some required libraries, and which are starting with pip. We are doing pip install all these things. We need Q, diffusers, transformers, accelerate, torch, save fences, and gradio, then pillow. Okay, then run. We can run it by shift plus enter. It will run easily. Okay, we don't want to go and check here. Shift plus enter. So here we installed all the required libraries and how each of them perform here. For in case of diffusers help us to load diffusion model, and transformers handles the test processing. Okay, the torch is used for deep learning, and pillow is for image handling, and gradio will help us to build a simple user interface. So I believe you all get to know all these things before starting it, because we need a base before starting anything. Okay, so we need diffusers, transformers, torch, gradio, pillow. All this has a purpose. Okay, not just like a statistics which has no purpose with our life. Okay, so we need to import some libraries. Next, okay, then we are importing torch first. Again, we are importing torch. That is import from PyTorch, import torch. Then we need to import diffusion pipeline. So we already installed the diffusers. So now we are going to import the diffusion pipeline. Stable diffusion. Okay, from diffusers, import stable diffusion pipeline. And now we are moving to import images, import image handling library, that is from pip Pill, import images. The image is in capital I. So pill is for pillow. We import image. And our last one is import Generative for the UI. Import Generative as GR. Run it. Now we import the libraries. Tools help us to work with GPUs, and Stable Diffusion pipeline load the pretrained model. This is what load the pretrained model. And Pillow handles images. PIL for pillows. Pillow handles images. And the video is used to create a interactive interface. Okay, we get everything. We install everything. We get a checked in. Okay, now all these imports are installed. The third step is we need to load the pre-trained diffusion model. So now we are going to load a pre-trained diffusion model. And first we need to define the model ID from Hugging Face. Okay, here the model ID is so here the model ID equal to, in double quotes we give runway ml, then slash stable, then hyphen, and then we write diffusion hyphen v1 and 5. This is our model ID. Now, I don't know whether. And now we need to detect whether the GPU is available. We again trying to detect GPU is available or not. So for that, device double quotes CUDA, and if toast.CUDA is available, else CPU. Okay, there's an indent. Because of that, the error came. So it run correctly. Now we need to load the pretrained stable diffusion model. So we are going to load the pretrained stable diffusion model. So for that we need pipe equals to stable diffusion pipeline dot from pretrained and model ID comma torch, just like this. Torch data type dtype equal to torch dot float 16. If device equal to CUDA, then else torch dot float 32. Okay, and we need to move the model to GPU or CPU. Okay, for that pipe equal to pipe dot to device print f model loaded on device. Now it's loading. It may take some moment. So here we load a pretrained stable diffusion model from Hugging Face, and then this model was already trained on large images. So image to test datasets, so that we don't want to train it anymore. If we want to do or learn from scratch, we should train a model with millions of images. So that is not done by us most cases while doing a project. And while you are facing an interview, the interviewers asked what you have done. So just say you trained the model. Okay, don't say you built it. And this model was already trained on large datasets like images to test datasets. And we check whether the CPU is available. Okay, each line has a hashtag, so you can understand each line if you skip this video or not. So I will post it in my GitHub. You can check in and take it from there. Or if you are really interested in this and do it with me, it will be much more helpful for you. And then we move the model to, if it is CPU or GPU, we move it to the device. The model, it's not creating images yet. It's just being loaded into memory. This is what happening here. The loading will be finished now. And we check whether the GPU is available or not and load accordingly. Okay. The model is now created. Everything is created, model loaded on CUDA. So everything is set. So this is the next step we want to take. So this is the step that only happens once. So now we are going to define the image generation function. So this is the function which is a core part of our project. So let's do it. We are going to generate images soon. Define the image generation function. Okay, we are going to generate images. Def generate image prompt, then colon, triple quotes, generate an image from a test prompt, and triple quotes continued, image equal to type prompt dot image 0 and return image. So here what happens, it takes a prompt as an input. Here we already gave the prompts, and it takes a prompt as an input, passes into the diffusion model, and it passes a test, this prompt to the diffusion model and returns the generated image. So each time this function runs, a brand new image is created. So let's run it. This is where we create our text. Testing the test to image generation. So we are giving an example prompt here. So my prompt is, you can give yours now. Futuristic city at sunset, cyberpunk style. Okay. Now we are going to generate the image. Image equal to generate image prompt, then image equal to generate image prompt. Oh, I just wrote it 2 times. Okay, now we need to display the image. So here we test the model using a sample test prompt. The model starts from random noise and gradually refines it until it matches the description of a futuristic city. So let's run. Yeah, hope this works. So this image did not exist before. It is generated in real time. So yeah, we are generating an image by our own. That's amazing, right? There might be some... so we got an error. Just move up and scroll above and just write S here. Here we need to reassure its images and now run it. Yeah, you will definitely wonder. So this is our core function of our project. And yeah, look, it is amazing. Yeah, right? So it generated an image. Wow. I'm so happy to generate a new image. Let's run it again. Will it change? Or it is just fetching an image. Let's look. No, it's not fetching. It's creating an image. Okay. So yeah, we done it. We done. We are really proud of ourselves because we created an image using the text. Okay, now we need to build interactive web interface using Daddio. Okay. So we are going to create it. Wow, I'm so excited to create. Create Daddio interface. Interface equal to gr dot interface and a bracket. Fn equal to generate image, comma input equal to gr for Daddio dot text box, and again open a bracket. Lines equal to 2. Placeholder equal to enter your prompt here, close it, your comma, and then output equal to image, comma title equal to text to image generation using Stable Diffusion. Just losing my mind. Okay, and description equals generate images from test using a pretrained model. Okay, yeah, now we are going to do that. We need to launch the interface. So interface dot launch. Yeah, we are going to do it. Where did we miss a comma? Here. Let's wait. Let's wait for a few more minutes. I mean, few more seconds. It's loading. Yeah. Wow, this happened. Now we are going to write something. So now we created a simple web interface using Daddio. The user enters a test prompt, click generate, and AI creates an image instantly. This makes the project interactive and user-friendly. So let's write a test. A woman with a dog. Time can be seen here. We can just wait for a few more seconds. Yeah, now look, the image is shown. Wow, the woman with the dog. Can we choose another image? We can also have an option to download. Okay, we can write some other prompt like a dog walking to a park. It takes up to 10 seconds. It will show, yeah, the dog is walking through a park with a woman, but still it made the image. Okay. Whatever we wrote here will be made up into an image. Okay. So a village area. Now we created a lot of images. Oh, so cute, right? Yeah. So to summarize, we used a pretrained diffusion model to convert text into images. The model does not fetch images, it generates them. So this project demonstrates how generative AI systems are built in practice. In the next video, I will explain the code in more depth if you want. And yeah, we done it. So we need to say build a test to image AI system using a pretrained diffusion model. Don't say I trained a test to image model from scratch. Okay, we just build it. So it's a great project for your resume, and if you learn it clearly and make your own changes, this will be going to blow your mind. Okay, thank you for listening to this and keep learning. See you.